All right, so let's, oh, I closed Eclipse for some reason. Oh, that's right, I installed the new Android Studio yesterday, and I think it forced me to kill Eclipse. All right, so homework assignment was, we wrote the algorithm in class last time, but it was to convert that into the Java version of it. Is that right? For taking a string representation of a number and turning it into a integer representation of that number. All right, so before I go any farther, let's discuss a couple of issues we've had with the homework assignments recently. So I've mentioned multiple times in class that we have to solve problems in terms of the tools that are currently sitting in our toolbox, right? Okay, so when I give you an assignment, I'm purposely giving you an assignment with the assumption that you're only going to use the tools that are in your toolbox that we've introduced in class. All right. Several of you are finding nice little working solutions on Google that are perfectly reasonable solutions once you've understood some of these other things. But for example, before we wrote index or used index.of, built, before we started using that passively, we wrote our own version of index.of, that type of thing. I promise you, the function that was for your homework assignment tonight, there is an equivalent built into the language. I'll show it to you today after we'll write the solution, but we want to appreciate the things that are built in. So kind of the common thing that a lot of folks use for the last assignment was a string method called remove all. So remove all is, hey, it's a perfectly reasonable function, but it's not something we've introduced yet. So, what I really encouraged you for before that assignment says, index of is your friend, that type of thing. We were looking for you to really explore and practice the index of thing. So when you're doing your homework assignments, only use the stuff we've introduced in class. There's a method to the madness. All right, so finding solutions online isn't a bad thing, especially if you're working or something. There are a couple of you that as part of your self-evaluation use the correct words, and I didn't dock you points, but I told you what to do. So if you want to search for those words, if you got a bad grade and tell me why you used other things, I might give you points back, but I won't tell you what the right words are. So you have to explain why you use something other than what we had covered in class specifically. All right, questions about that using just things that we've introduced? So right now our toolbox is fairly sparse, right? We know about ints and chars and loops. Within strings, we know about length, char, at, and index of. That's the limit of our world right now. And we'll keep adding new things to that. We make lots of trips to Home Depot in here. Right? We run over there, we bring a new tool, drop it in, and go to town with it. Okay, so last time we created this algorithm for converting a string into an integer. So we're going to need a couple of variables, one to hold the current place, because this goes back to what is it, first or second grade math when we learn how numbers work. So, the number 124, I think we used as our example or something like that. The 4 is in the ones place, the 2 is in the tens place, the 1 is in the hundreds place. We add all those together and we get our actual final value. All right, so we're going to need Java to do that work for us. All right, so let's go into Eclipse here. And here's our string to int that takes a string as a parameter and ultimately returns the integer equivalent to that. We're going to assume that what you pass it is the string representation of a number, not that you're going to pass it the string cat and hope you get a number out of that. That would go sideways pretty quickly. All right, so our algorithm says we're going to need a couple of variables. So one to hold the current place and another one to hold our running total. Okay, both of those will be integers. So we'll have int place, and we'll start that off at 1. We'll have int total, we'll start that off at 0. So total is going to be a guy that keeps summing up all of our things. Then the algorithm says walk our string from backwards, from the last legal position all the way up to and including bucket 0. So that's our stock for loop for going through every index of a string, but this one's the one in reverse. All right. And again, just to kind of keep reiterating this, the loop itself has nothing to do with strings. We just happen to be taking the counter on a voyage that we can utilize it as part of the index of a string. Okay, the for loop has nothing to do with the string until we actually make that connection ourselves. So we'll write our stock loop for int I is equal to the number of characters in s minus 1. So that's s dot length minus 1. Some things I'm still seeing folks do in the homework assignments are things like that, where they've just decided, well, this isn't generic anymore, I'm just going to go ahead and throw my own string in there, rather than relying on us passing some string to our function. Okay? So remember, methods, functions, whatever you want to call them, are meant to be generic. That's why these parameters exist. We can call this guy 10 different times, passing it 10 different strings, and each time s.length is the number of characters in the string that it was passed with. Make sense? All right, so I is going to be the last legal index in S, which is s.length minus 1. We're going to keep going as long as I is greater than or equal to 0. And we're going to subtract 1 from I each time. Did we do the minus, minus, plus, plus stuff last time? All right, so we're allowed to use that now. Interesting kind of trivia knowledge for another modern language is the Swift programming language is getting rid of minus, minus, and plus, plus. To be honest, I'm not even sure why. Let's look at that real quick. See if there's a good Swift removes plus, plus. See if they explain why. Yeah, so this is related to what we've talked about in class, that, you know, this stuff is a carryover from C. Those things have been around forever. Okay, so this is the exact same stuff we talked about in class last time. So this is the Swift programming language, so it shouldn't look too different. Let's see, what's the disadvantage? All right, well, so this is related to what we talked about last time. So you have to understand how that plus plus and how that minus minus actually work, whether it comes before or after. So it's adding an additional burden. I don't know if that's necessarily a real problem, but all right, so they're claiming that x plus plus is not that much shorter than x plus equals 1. And this guy is much more. We talked about the plus equals operator too, didn't we? Okay, so this is much more powerful because now we're not limited to just incrementing by 1. We can increment by 5 or 7 or decrement by 3, whatever we want to do. So in that one syntax, we can do all sorts of stuff. Where I think I used the example last time or the time before, whenever we introduced it, x plus 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 won't fly because we're trying to change the value. Like if x is 5, x plus plus will boil down to 6. Well, actually, it'll boil down to 5, and then the plus plus after. So let's say plus plus x would boil down to 6. And then if we try to plus plus that, we're trying to change the value of 6 to be 7, redefining what the integer 6 is. So that's not going to fly. So they're really saying there isn't a huge advantage of this over something like this. They're saying it's already okay because Swift deviates from C in other ways, so they don't have to maintain this connection to C. All right. So effectively, which is kind of funny about Swift, because effectively they're saying, well, it's kind of a waste of time. Let's not add this extra syntax. Where and you remember earlier in the semester when we introduced Swift and talked about kind of the mentality for why Swift exists, it wasn't really the upgrade to Apple's Objective-C. It was to get folks to come over to the dark side, get the Java people to come over to start writing iOS apps in Swift, get the web programmers to come over and write iOS apps in Swift. Good.
Isn't Swift like relatively new?
Yeah, it's 2 years old, really. It's probably been very popular for 1 year. But yeah, it's the newest. If you remember back from our evolutionary picture somewhere near the beginning of the semester here, this guy, we have it all the way down here in our little. So Java's up here. Swift is many years newer. So Java came out in like 1995 or something like that. Swift is 2014-ish, something like that. Probably about a year ago is when people who were sitting down to write a Mac or an iOS application would by default start the application as Swift. Before that, it was kind of like, oh, Swift is new, let's dabble in it, but we're probably going to write it in Objective-C. Today, the only people who are writing Objective-C stuff for iOS are, for instance, some of my students are employees at Uber. And so I do their onboarding process for the Uber way of writing iOS applications. And Uber still uses Objective-C because their application has been around for 7 years. Well, so a majority of it is written in Objective-C, so why deviate from that? So their developers are writing all the stuff in Objective-C. So unless you're in that situation, it's you're pretty much using Swift. But what's funny about this is, you know, they're saying Swift already deviates from C, and you know, why do we need 2 ways of doing this when this guy's almost as short? Well, in Swift, you have like 30 different kinds of loops. They've basically taken all of these web programming languages that have, you know, a whole bunch of different for each loops and for things in a range and all sorts of things, and they just said, well, we'll just support them all, you know, rather than kind of narrow people down into a single thing. So Swift kind of deviates from the statement. The Swift way of doing things would say, yeah, let's go ahead and keep X++ and ++X because people already are used to it. We'll add some, you know, we'll let them use this too. And actually the Swift way might even be to invent a new one, you know, just a brand new syntax for incrementing stuff. They've done plenty of that as well. Yeah, but interesting trivia thing as we're talking through this, that the ++ operators are being evolved out of some of our modern languages. All right, but we'll keep using it here. So I is equal to the last legal index in our string. We're going to keep going as long as I is greater than or equal to 0, because we want to include bucket 0 because that is a legal position. And we'll subtract 1 from I each time. Does it matter if I say I minus minus or minus minus I there? Okay. Ultimately, it will boil down to the same value for when the next time we need it is. Since we're not using it in line, we're not using it again in that exact position, it won't make a difference for us. But under the hood, it is working differently. Those two do different things within within that window. But it won't matter what we say there, whether we say I is equal to I minus 1, or I minus equals 1, or I minus minus, or minus minus I. Those all mean the same thing in this context. All right, so now what are we doing each time through? We need to determine which character, or what is the number associated with the character we're currently looking at. So we need to convert the current char into an integer. And I think we wrote a function last time that does that for us. Just uses our index of trick, right? So char to int uses index of on the list of all the digits. So the first index of 0 would be 0. The first index of 1 would be 1, so on and so forth. So we're going to go ahead and call upon this function. Is this guy a class method or an instance method? Class method. How do you know? Static. How do you call class methods? Yep, using the name of the class in which the method was defined. And what's the name of the class this guy was defined in? Driver. So we'll say driver dot char to int. We'll pass it a character. The character we're going to pass that guy is the current character in our string we're interested in, which will be s dot char at the current value of I. We'll pass it to char to int. Char to int will spit out the integer equivalent of that char. All right. So we'll go ahead and say driver dot char to int s dot char at I. So this guy right here will boil down to the integer equivalent of the current character. All right, and what are we supposed to do with that guy? We're supposed to multiply it by our current place. So multiply that by our current place, and then add the result to our running total. Total plus equals that, or you could say total equals total plus that stuff. All right. And if you want to be explicit, Java knows order of operations, so it knows that multiplication will come before addition. But if you want to ensure that, it's not going to be wrong to throw parentheses around that. All right. I usually encourage that type of stuff. Be explicit about it rather than relying on Java to do something that you might know it already does, but it makes the code clearer here. Some of you might choose to store that information in a separate variable and then add the variable to that. If that makes you feel better, that's fine as well. All right, so total plus equals are the integer version of the current character times our current place. All right, and we've added it to our running total. So that one line does those three things. All right, then we need to change the value of place to be 10 times bigger than it used to be. A 1 becomes a 10 becomes 100, so on and so forth. So we'll go ahead and say place times equals 10. So I'll make place bigger than it used to be. Or you can say place equals place times 10. All right, it's going to keep running through our string, and in the end, we can go ahead and return total outside of the loop. So we're going to do this for every single character in our string, incrementing, well, multiplying by 10 for the place each time, adding stuff to our running total. Ultimately, when we're done processing the string, we'll return the current value of total. That make sense? And then to test this, we'll put 124 in here. And let's go ahead and do a system.out.println s plus 5. Okay, and that's going to give us 1, 2, 4, 5 as a string, as opposed to system.out.println driver.string to int. What string? The string s plus 5. Okay, so this first one here, the plus sign is viewed as the concatenation operator because at least one of the sides is a string. All right, so it's going to say, oh, well, this guy's a string, so we're going to concatenate the integer literal. That's what that guy is. That is the integer literal with nothing around it. This is the char literal 5. This is the string literal 5. That makes sense? Now, realistically, if I don't put anything around it, that isn't by default an int literal. That is potentially a variable to begin with, but variables can't start with numbers. So not a variable, must be something else, or it's an error. In this case, that is the integer literal 5. Okay, so you can't have variables that match our integer literals. Part of that has to do with you can't start a variable name with a number. But this first one's going to say, well, this is the concatenation operator, so we're going to take this string and we're going to glue on to the end of it whatever that is, whether it's an int, whether it's a char, whether it's a string, whether it's a double. Doesn't matter what that guy is, we're gluing it onto a string, not doing math with it. All right? In this case, this guy right here ultimately boils down to the return type of string to int, which is an int. All right, so everything we have highlighted here, even though it looks like a lot of stuff, ultimately will just be a number, an integer literal. Therefore, the plus sign is going to look both ways before crossing the street and say, the guy to my left's an int, The guy to my right's an int. These guys are both numbers. They're mathable. I think that's probably not a word, but I just invented it, kind of the chill thing, right? I think. No, she doesn't think so. She's just appeasing me at this point. So these guys are mathable, so we'll go ahead and add them together. This is going to give us 129 as a number. All right, that'll be the proof that this guy's working. All right, so there's our 1, 2, 4, 5, and there's our 129, proving that our function is indeed working. Make some sense? All right, so question. What if I had that? So I have a negative sign now. Kind of makes sense to us that all numbers aren't positive numbers, right? So does our current function work for negatives? Go ahead.
No, because it'll go into it and create an error. It
Yeah.
register as a number.
Yeah, it's gonna. Well, it actually. I don't think it's gonna create an error. Let's look at this real quick, because when we go to char to int, trying to get the int version of a minus sign, we're gonna look it up in here, and ultimately we're gonna return a -1, won't we? Doesn't this guy return a -1? All right. So what are we going to do with that -1? Well, as we go through here, we're going to multiply that -1 by our current place. So that's where things get thrown off. So we multiply the -1 by our current place. Because then we just get some giant number that's all wonky. So if I go ahead and run this, you'll see that it's not an error. We just have a wonky number. All right. So effectively what we have is -1000 plus the difference. Okay? So how can we fix this? Now again, we're assuming that what we're passing it is a legal number. So in our world right now, we're going to say that every legal number has only integer, has only digits in it, or starts with a minus sign. Okay? We're going to say a plus sign is not a legal number. If you want a positive number, you just omit the minus sign. All right. So how would I modify my code here to work on that minus sign? A couple different ways we can do it. One way is pretty straightforward. The other way is going to be the way we just explained that works, but will be less straightforward. So how would you want to modify this to make it work for negative numbers? We got a quarter of a hand back there. We'll take it. Okay. We can do an if statement that checks to see if it's a -1, or we could also do an if statement and says that looks at the current character, and before we just haphazardly convert it to try to convert it to a number, we say if it's a minus sign, don't do any multiplication stuff. Let's just multiply our current value by -1, something like that, right? Bottom line here, from a programming as a skill set perspective, what do we do to handle that special case? We ask a question, right? Before we go down a bad path, we're going to ask a question. All right, so inside of here, when we have our running total, this is the current character. So I'm just going to go ahead. We're going to create a variable to hold this guy temporarily, just because we're going to possibly do some logic on him. So we'll say curchar, and then we'll set curchar equal to that dude, which then allows us to just change this to curchar. None of our logic has changed at this curchar. Should have called it curchat since that guy's winning the battle here. All right. And this is char to, oh, this is actually going to be we just want it to be this dude. So curchar will hold our character at I. So this is going to be a char. Then when we know we're going to do math with it, then we can say driver.char to int that char. All right, but right now we're holding on to cur char. So before we do any mathy stuff, we're going to ask a question. We want to know if cur char is equal to the minus sign. We're going to do something different, right? Okay. If we're looking at the minus sign, doesn't that mean, since we're saying we're assuming that they're passing us a legal number, doesn't that mean that this is the very last time through the loop for us? The only place we can have a minus sign is at the very beginning of our string. Again, assuming the person passes us a legal number. So we know that we've already collected our final value inside of total. And if we see a negative sign here, all we need to do is go ahead and return total times -1. Right? We'll just make it a negative number. So we'll go ahead and return total times -1. So conditionally, as we're going through here, we'll ask a question. This guy right here is kind of like a minefield. Should we jump out of the car now? All right, if I'm looking at a minus sign, I'm going to say, oh, we must be done. My final answer is in total, but before I return it, I'm going to multiply it by -1 because that minus sign just told me this is a negative number. Make some sense? All right, so what does the return statement do? Return keyword. What impact will that have on this function? If I ask this question, I get a true from it, and I get to this line of code. Function's over. Ends. Dead. Okay? We will never get to this line of code in that event because this will make the function immediately end returning this value. Okay? So as we have this written right now, it's fine. If it makes you feel better, you can throw an else in here and then put this stuff inside of the else so that structurally it reads a little cleaner rather than you having to remember that return makes something immediately end. Probably not something that would be a bad assumption to make. That's one of those things that we should all remember at this point. But we're asking the question, if this is true, do this. Otherwise, go ahead and do the normal stuff. All right, so this isn't incorrect. So we'll have equivalent output to what we had a few minutes ago. Okay, so now this guy should work for negative numbers. And, ooh, hold on a second. Why did we get a -19? Oh, thank you. All right, see, I was testing you. He passed. You did not. Yeah, no. It's the weighted throw thing. It's going right to your... That's what a weighted throw? Yes, chill. See, I'm practicing. That's right. See, I want you guys to practice the stuff we've introduced in class, and I'm practicing the stuff you've introduced in class. So it's a two-way street here. Yeah, I think I'm doing at least B- work. Right? I've only used chill out of context like half the time. Okay, but the other averages are high. I'm pretty funny, I think, right? Ish. Yeah. I mean, more entertaining than half of your teachers probably. Don't you sleep through most of your classes? Yeah, he sleeps through half of my classes. The funny thing is, so at least he sits in the back. I've had students sit in this chair right here and just conk out. I mean, I'm pretty loud. I mean, wouldn't you think I would just scare the crap out of them half the time? All of a sudden I'd say something, just jump up. I usually just slap the desk like that. It's pretty funny. Yeah.
Teacher in high school that if you fell asleep, she'd everyone would be quiet and just walk out of the classroom.
Everybody abandon the classroom and then just make a loud noise and let them wake up. Just they wake up in an empty classroom.
And then she'd set the clock over past 5 p.m.
Oh, that's going kind of, but I mean, not a bad idea, but that's pretty aggressive. Yeah, really freak them out.
Yeah, it's 5. I still have to do the rest of my school day.
Yeah. It might make more sense, I think, if you blacked out the room and then woke them up. Okay, all the doors are shut. Okay, and the room is pitch black, and they wake up in darkness. And if you really want to take that to the next level, play from the Nightmare on Elm Street movies. The kid it's like 1, 2. You just actually have that going like on an iPhone in the corner, just so they hear that little chant going. that could get somebody in trouble probably. Great idea. We should definitely do it. All right. So questions about this one? It's doing our conversion stuff. Okay, so now that we can do this by hand, I'm going to teach you one tool that exists. But you can only use the exact tool that I'm introducing. Okay, there's 2 versions of this tool. Okay, there's the cheapo version from Home Depot, and then there's the more expensive professional model. All right, and I'm not teaching you the professional model yet because that will make your next homework assignment too easy. But I'll show you the cheapo model for now. That'll benefit you even on the next homework assignment. So what we can do here is we can say system.out.println integer.parseInt s. And we'll do the +5 thing there so it matches. All right, and we're going to talk about this here in a second. So integer.parseInt takes one parameter, and that parameter, in fact, let's go look at this in the documentation just to, so we'll do java.sun.com. Java APIs. And we'll go to java.lang just to call this list a little bit. We're going to go down to a class called integer. Now, actually, before I go any farther, this is me calling a function called parseInt. Is parseInt a class method or an instance method? And how do you know? So we're looking at a method actually being called here. Is this a class method or an instance method? And granted, you cannot tell me at this point with 100% certainty, but you should have a very, very, very strong suspicion. You technically can tell me with 100% certainty because I just showed you enough in the documentation for you to draw that conclusion. But just based on what I have highlighted there, is parseInt a class method or an instance method? Okay, you think an instance method? All right, tell the class why you're wrong.
I was just thinking because you're not calling driver.
50-50. Oh, okay, so I'm glad you went down that path. So we're not saying driver in front. Well, we call class methods using the name of the class in which it was defined. We've used driver in front of all of ours because we define those class methods inside of driver. Okay, well, we saw last time there's a whole bunch of classes that we didn't write. Classes that are not called driver, that have stuff in them. So we would call those methods using the name of those classes, okay, the class in which those methods were defined. All right, so you said this was an instance method. I said that you to tell the class why you're wrong. All right, so your bad answer to that was because we didn't use driver. Okay, yes, I'm spoken like a true weighted throw amateur.
Mediocre.
Well, which is better, amateur or mediocre?
I think mediocre is worse, but it sounds better.
You just have low standards. I get it. All right, so must be a class method. Tell me why.
Because it's owned by the integer class.
Okay, seemingly the way I'm calling it is with something called integer. Now, locally here, we don't have a variable called integer, right? So evidence suggests this guy's not an instance, first of all, and Eclipse has not underlined it in red, so this is legal code as we have it written. So I don't have a local variable called integer, so it must not be an instance. Likely then it's a class. When we look at the word integer, is there anything about it that clues us in as to this guy is probably a class? Yeah, classes typically start with capital letters. Okay, it's not a rule. Java doesn't enforce it, but if you notice that we've named our class driver with a capital D, and whenever we've created variables, we tend to start them with lowercase letters. Here's a good example down here. Char. Again, not a rule. You can start variables with uppercase letters if you'd like, but it happens to be a naming convention in programming languages. Variables start with lowercase characters. Objects, classes start with uppercase characters. All right, so 98% chance you can rely on that. Okay, so this guy, what's this affluenza thing? Some Texas kid said that he broke all these rules because of affluenza. Yeah, what is? Yeah, but I don't think it actually is. Didn't he just say it's because his parents didn't teach him like rules?
It's like a cop out.
Yeah, yeah. Well, apparently he got 2 years in jail. So
How young is he?
I have no idea. It says teen, so yeah, less than 20. What was it talking about? Oh, class methods. Blame that on the Apple Watch, not my fault. All right, so we can suspect this guy is likely the name of a class because it starts with a capital I. Therefore, if we're calling a function or a method here, I'm using those words interchangeably. We're going to call them equivalents to each other. So if I'm calling one of these guys using the name of a class, this guy must be a class method. Specifically, he must be a class method that was defined inside of this class. So I should be able to go to the documentation, find a class called integer. Inside of there, I should find a method definition for something called parseInt. And what should I see as part of that method definition? What do you expect to find at the very least in the method definition of a class method? This was your quiz from last class. So today I've asked you to identify a method as being a class method or an instance method based on the way we're calling it. Last class you had a quiz. Actually, 2 classes ago you had a quiz. Last class, half of you didn't show up, so we had a quiz. Freebie quiz. All right, so 2 classes ago, it was when you're looking at the method definition, how do you know whether something is a class method or an instance method? What will we find in the method definition? Static. Find the static keyword. So since we're identifying this guy as a class method that lives inside of the integer class, when we go and look at the integer class and we find the method called parseInt, we expect to find static there. Okay. Otherwise, Eclipse has a bug in it and has identified this as not being erroneous when it is. So here's our integer class. We'll scroll down, and remember, you're going to find more than one of the parseInts here, but I'm only officially introducing one of them. I'll highlight the one I'm introducing. All right. So down here we have something called parseInt. All right, so don't look at this one. That one's not one we're introducing here. We're just introducing this one. All right, so here's parseInt that takes a single parameter, a string, and it returns an int. And notice this guy is a static method. That tells us it's a class method, therefore we call it using the name of the class in which it was defined. Make sense? All right, so there's parseInt. I promise you next class, after you do your homework assignment, I'll introduce this one. All right, that'll be helpful. Not allowed to use it in your homework assignment. All right, but our current parseInt knows how to take in a string representation of a base 10 number and convert it into an integer, which is also a base 10 number. Make sense? All right, so now we have some of these tools. We now have well, not really an upgraded version. We have a replacement for this function, which it lives in the integer class called Integer.parseInt. That basically does the same thing as this guy does. So we have 2 classes that are identical to, we have 2 methods that are identical to each other. One that was built into the language and one that we wrote ourselves. Okay? Choose your poison, you can use either of those. Now, let me ask you this. why do you suspect that the parseInt method here, which operates on things related to integers, why do you suspect that it is a class method? Why did they make that a static method rather than an instance method? And as a follow-up to that, we might say if they were to make it an instance method, who would it belong to? It would be an instance method of what class? Probably the string class. It might be helpful for us to ask a string to give us the integer version of itself. Make sense? So if we had the string s in this case, that's -124, it might make sense to just say s.toInt. Give us the integer version of yourself. Okay? But they went the other direction. They said we're going to put this inside of the integer class, okay, which is a class meant for doing things to ints, okay, doing things int related. And all the methods in that class, there might be one or two, but I think a majority of them, if not, probably all of them actually, are class methods. Why do you suspect that they're class methods? Why did they make them all static methods as opposed to instance methods? Well, I just mentioned that the integer class, let's go to our slides here. Why are methods in the integer class static? All right, so we can kind of answer that from the flip side. Why do instance methods exist? Well, we've seen in the string class that we have methods that are instance methods, like length, char@, index_of. These are methods that operate on the string that called them. So if I call the length method on the string hello, I get a 5. If I call the length method on the string elephant, I get an 8. All right, so those guys operate on the calling string. Make sense? Why do you think the integer class has all their stuff as static values? Let's think about ints in general. What is an int? Is that an object type or a primitive type? We talked about two different types of variables. We have object types and primitive types. So what's a primitive type variable? Well, our examples of those are byte, short, int, long, char, float double, boolean. Those are our primitive types. So those are the ones that are built in. Well, what is it about a primitive type that makes it a primitive type, besides it being built into the language? It can only hold a value. That's it. They only know how to hold values. They don't know how to do additional magic tricks. When we introduced object types, we say they can potentially hold 0 or more values, but they can also do more. So when we think about the string class, for example, it's probably under the hood holding a character array, an array of characters, but then it knows how to do all these magic tricks to its stored value. Okay, well now we have this dude over here called an int, which is a primitive type, and that guy only knows how to hold values. It doesn't have even the capability of having magic tricks associated with it because it's a primitive type. With that in mind, if we want to do things related to ints inside of our language, it might make sense for us to create an object type related to ints. So they created this integer class. And inside the integer class, we have a whole bunch of methods that are effectively magic tricks that can operate on ints, right? Now, or operate on things int related. When we think about the string class, for example, the string class really has two capabilities. On one hand, it holds the value of a string. On the other hand, it can do things related to that string. So that's why that guy is filled up with a bunch of instance methods. Okay. He's filled up with instance methods because he also holds an instance value. The integer class doesn't hold a value of an integer. to operate on. Instead, it just holds magic tricks to operate on external integer values. And the reason for that is we don't need two ways of holding ints. We already have a way of holding an int. It's called an int. Okay, built into the language, we have the capability of holding integers and chars and booleans. All right, they can't do anything else. Their weakness is a lack of magic tricks. We don't need to invent a new way of holding ints. We already have that way. That's why we have a class like the integer class. We also have a class called character, a class called double, a class called float. We have classes for all of our primitive types for doing these things. Make sense? All right, so that's why that guy exists. So in this particular case, we have the ability to take in a string and turn it into an int. It's a integer magic tricky thing. That's why that ability exists. All right, so let's go back in here. Let's see. Let's do. So for our homework assignment, we're going to write a function here called binary to integer. All right, so we've had a couple of conversion problems, right, where we've looked at converting a binary number into an integer. So this guy should take a string representation of a binary number as a parameter and return as an int the decimal equivalent. So for example, it could take in 1011 and it would return, this is the ones place, the twos place, the fours, the eights, so this would be an 11. 1, 2, 4, 8, so this is 8 plus 2 plus 1. This guy would boil down to an 11. Make sense? Problem you're solving? Okay, so a function that takes in a string representation of a binary number, like this, ones and zeros, spits out as an integer the decimal equivalent. Questions? All right, so that is for Friday. Hint, I think you will find this function to be very similar to our function down here, string to int. All right, so what we're really trying to drill here is that the difference between these different number bases isn't that much. But because we're used to decimal and not these other bases, it's intimidating for us. All right, so you're going to see the code is very similar. But remember, you're only allowed to use, if you choose to use integer.parseInt, the one version of parseInt I've introduced. The other guy does this job for us. All right, we're not going to be able to do that one yet. Okay, I will see everybody on Friday.